Imagine a country that is famous for discipline, planning, and engineering perfection. A country whose factories power Europe, whose machines run the world, and whose economic decisions influence global markets. Now imagine that same country spending more than $500 billion over 2 decades on a single grand project that promised clean energy, energy independence, and climate leadership, but instead resulted in higher electricity prices, weaker industries, deeper geopolitical dependence, and a national debate about whether the entire strategy went wrong. This is not an exaggerated headline, and it is not a political attack. This is Germany's $500 billion mistake, officially known as the Energiewende, Germany's energy transition. To understand why this matters so much, we first need to understand one simple truth. Modern economies do not run on intentions, they run on energy, affordable, reliable, and continuous energy. Because without it, factories stop, jobs disappear, and living standards fall. This is exactly why Germany's case is so important for the entire world. Before the Energiewende, Germany actually had one of the most stable and efficient energy systems among industrial nations. In the early 2000s, its electricity mix was balanced. Nuclear power supplied roughly a quarter of total electricity. Coal provided reliable baseload. Renewables were slowly expanding. Electricity prices were predictable. This stability allowed German companies to invest long-term. Chemical plants, steel mills, automobile factories all relied on the assumption that energy would remain affordable and available 24 hours a day. The original idea behind the Energiewende was not extreme or reckless. The plan was gradual. Reduce emissions step by step. Scale up renewables over decades. Keep nuclear power as a low-carbon bridge until alternatives were fully ready. But this carefully balanced plan changed suddenly in 2011 after the Fukushima nuclear disaster in Japan. An event that shocked the world emotionally, especially in Germany, where anti-nuclear sentiment already existed due to historical and cultural reasons. Even though the disaster occurred in a tsunami-prone region thousands of kilometers away and involved risks that do not exist in Germany, public fear rose rapidly. Political pressure intensified. Within days, the German government announced an accelerated nuclear phase-out. 8 nuclear reactors were shut down immediately, and the remaining plants were scheduled for closure. This removed a massive amount of stable, low-carbon electricity from the grid in a very short time. This decision is critical to understand because it was not driven by new safety failures discovered in German plants, nor by engineering studies showing nuclear energy was unworkable. It was driven by public emotion and political risk. Once nuclear power was removed, Germany faced a structural problem that could not be solved quickly. Electricity systems are physical systems governed by physics and timing, not slogans. Germany tried to fill this gap primarily with wind and solar energy, supported by generous subsidies through the Renewable Energy Sources Act. These subsidies guaranteed fixed prices for renewable producers, encouraging rapid investment. In terms of installed capacity, Germany became a global leader. Thousands of wind turbines were built. Millions of solar panels were installed. But installed capacity is not the same as reliable electricity supply. Wind and solar depend entirely on weather conditions. Germany's geography creates a unique challenge. Long winters with limited sunlight and frequent periods of low wind, known as Dunkelflaute. During these periods, renewable output can drop sharply for days or even weeks, while electricity demand remains high due to heating, industry, and household use. Under normal circumstances, this variability would be balanced by stable baseload sources like nuclear power. But Germany had already removed that option, leaving fossil fuels as the primary backup. Coal plants stayed online longer than originally planned. Natural gas became the main flexible energy source because gas plants can ramp up quickly when renewable output falls. This created the second major vulnerability in Germany's energy strategy: gas dependency. Germany does not have large domestic gas reserves, so it relied heavily on imports, mainly from Russia. Pipeline gas was cheap and available at scale. By 2021, around 55% of Germany's natural gas imports came from Russia. This gas was not only used for electricity generation, It was critical for industrial heat, chemical processes, fertilizer production, and residential heating. The entire German industrial model quietly became dependent on the assumption that cheap Russian gas would continue flowing indefinitely. This assumption was based on the belief that economic interdependence would reduce geopolitical risk. But energy security is not only about price, it is about political stability. This vulnerability became painfully clear in 2022 when Russia invaded Ukraine. Gas supplies were reduced. Prices surged across Europe. Germany faced the largest energy shock in its modern history. Natural gas prices increased several 100% at peak levels. Electricity prices followed. Energy-intensive industries were hit immediately. Companies faced energy bills multiple times higher than historical norms. Production became unprofitable overnight. Some facilities reduced output. Others shut down permanently. BASF, the world's largest chemical producer and one of Germany's biggest energy consumers, announced long-term downsizing of its European operations and redirected investment to regions with lower energy costs. This pattern spread across industries. Steel, aluminum, fertilizers, and paper production all declined. German households faced some of the highest electricity prices in the developed world. A major reason was that the cost of renewable subsidies, grid expansion, and energy levies was passed on to consumers. Even after spending hundreds of billions of dollars on renewables, electricity affordability became a serious social issue. At the same time, Germany faced another less visible but equally damaging problem: grid infrastructure. Most wind energy is generated in northern Germany near the coast, while industrial demand is concentrated in the south. High-voltage transmission lines were planned to move electricity efficiently. These projects faced years of delays due to regulatory complexity, legal challenges, and local opposition. As a result, the grid often could not transport renewable electricity to where it was needed. During periods of high wind generation, grid operators were forced to curtail wind farms to prevent overloads. Producers were compensated for electricity they never delivered. Consumers paid billions of euros for power that was never used. Meanwhile, fossil fuel plants in the south were turned on to meet demand, increasing costs and emissions at the same time. This revealed a fundamental sequencing problem. Generation expanded faster than transmission, creating inefficiency rather than sustainability. By 2023, Germany's carbon emissions did fall to their lowest level in decades. Supporters of the Energiewende pointed to this as proof of success. But a closer look at the data shows that a significant part of this reduction came from declining industrial output rather than a fully successful replacement of fossil fuels with clean energy. When factories slow down, emissions naturally fall. This is not a healthy or sustainable climate strategy. Meanwhile, Germany shut down nuclear power, while neighboring France continued to rely heavily on it. France now has electricity that is several times cleaner per kilowatt-hour than Germany's. This means a German electric car is often charged using coal and gas-based electricity, while a French electric car runs mostly on nuclear power. Today, Germany finds itself at a crossroads. Economic growth has slowed. Political consensus has fractured. Industries are reassessing long-term competitiveness. Policymakers are openly debating whether parts of the Energiewende need correction. The real lesson of Germany's $500 billion mistake is not that renewable energy is bad. The lesson is that energy transitions must be realistic, gradual, and carefully sequenced. Stable energy sources should not be removed before reliable alternatives are fully ready. Grid infrastructure must grow alongside generation. Geopolitical risk must be treated as a core part of energy planning. Germany wanted to lead the world by example. In doing so, it created one of the most important case studies of modern energy policy. The question now is not just about Germany. The real question is this: if a country as rich, educated, and technologically advanced as Germany struggled this much with its energy transition, how should the rest of the world design theirs differently to avoid repeating the same $500 billion mistake?